Most welcome to you all in my YouTube channel, Learn Physics with a Clear Concept. Hope you are all doing well and I wish your grand success. In our previous discussion, we have learned about Kirchhoff's laws and its implementation in current electricity. Today, we are going to discuss about Wheatstone Bridge and its application to determine the value of an unknown resistance accurately. So, let us discuss about Wheatstone Bridge. Before going to discuss about Wheatstone Bridge, we may be mentioned here that we can measure a unknown value of a resistance by applying Ohm's law directly. Let us see the diagram. Here we can see one resistance R is there. It is an unknown resistance. One ammeter is fitted with the resistance in series connection, and from the ammeter we can get the value of rate of flow of current, and one voltmeter is fitted between the two ends of the resistance in parallel connection, and from the voltmeter we can get the value of potential difference between the 2 points of this resistance. So the entire system has been connected with a electrical source via one key, which we can say switch. Now if we switch on the circuit, then the electricity will flow in this direction, that is from higher potential towards lower potential, and total current I has been flowed through R and V. Then we can remember the mathematical form of Ohm's law. Mathematical form of Ohm's law is V is equal to IR, where V is the potential difference between the two ends of a conductor, I is the rate of flow of current through that conductor, and R is the resistance of that conductor. So from there we can get R is equal to V by I. We can get the value of V directly from the voltmeter, and we can get the value of I directly from the ammeter. So by applying Ohm's law we can get the value of unknown resistance. But if we determine the value of unknown resistance by Ohm's law, some error will come. Let us see how it happens. Here we can see the main current is I. It is passing through the ammeter, and after getting from the ammeter, it has been divided into two parts. One is through the resistance, that is IR, and other part is going through the voltmeter, that is IV. So I is the sum of IR plus IV. So we can say I is equal to IR plus IV. So obviously we can say IR is less than I. IR is less than I. So whatever I we are mentioning here, that is not I, that would be IR. So like this way we can get some error by determining unknown resistance through Ohm's law by this way. In order to remove these difficulties, in the year 1843, Professor Charles Wheatstone of London invented the process for the measurement of an unknown resistance accurately, which is called Wheatstone Bridge. Let us see about the Wheatstone Bridge. Here we are seeing a diagram of Wheatstone Bridge. we can see four resistance are there: P, Q, R and S. P has been fitted between A and B points, Q fitted between B and C, R is between A and D points, and S is between D and C points. Suppose the potential of point A, we can take it VA, potential of B, we can take it VB, potential of C is VC, and potential of D is VD. Now, one galvanometer has been connected between the points B and D, and one electrical source is fitted between the points A and C through a key that is called switch. Now, if the potential difference of point B and potential of point D is the same, that means if VB and VD are the same, then in that case no electricity will flow through the galvanometer. Once again, if the potential of B and if the potential of D are the same, that means if VV is equal to VD, that means the potential difference between B and D is 0, then in that case no electricity will flow through galvanometer G. So in this case we can say this is the null condition of the galvanometer or balanced condition of the galvanometer. Now, if we switch on the circuit, the electricity will flow from the higher potential towards lower potential. Here we can see the main flow of current, we can take it I. Main flow of current has been divided into two parts at point A. One is passing through P, I1, and the other portion is passing through R, that is I2. Now, in the balance condition, in the null condition of the galvanometer, no potential difference is there between B and D. So, the same amount of current which is passing through P, that same amount of current will passing through Q also. So, I1 current will be passing through Q. Accordingly, I2 current will pass through S. Now, if we apply Ohm's law between the points A and B, we can see VA minus VB is the potential difference between A and B divided by VA minus VB divided by resistance is equal to I1. Once again, VA minus VB by resistance, V by R is equal to I1. And the same current is flowing through Q. So, we can say VB minus VC by Q is equal to I1. Here we have written VB minus VC by Q is equal to I1. So, this is equal to I1 and this is also equal to I1. So, we can say this is equal to this. That means VA minus VB by P is equal to VB minus VC by Q. So, we can get P by Q is equal to VA minus VB by VB minus VC. And here, if we apply Ohm's law between the points A and D, then we can get VA minus VD by R is equal to I2, and in the conductor DC we can get VD minus VC by S is equal to I2. So this is equal to I2 and this is also equal to I2. So we can say that this is equal to this. That means VA minus VD by R is equal to VD minus VC by S. So we can get R by S is equal to VA minus VD by VD minus VC. VA minus VD by VD minus VC. Now, in the null condition of the galvanometer or balanced condition of the galvanometer, we know that VB is equal to VD. VB is equal to VD at the null condition of the galvanometer. So we can write VB in place of VD. So we write here VA minus, we have written VB in place of VD. Here also in place of VD we have written VB minus VC. So what we get? VA minus VB by VB minus VC. That same we have got previously. VA minus VB is equal to VB minus VC. So P by Q, VA minus VB by VB minus VC. Now here R by S is equal to VA minus VB by VB minus VC. So we can say P by Q is equal to R by S. This is the mathematical form of Wheatstone Bridge. So from the Wheatstone Bridge we can calculate, we can measure the value of an unknown resistance accurately. So in Wheatstone Bridge we set that unknown resistance in the points between D and C. So in place of S we place the unknown resistance. We use P, Q, R. These are known resistance, known value of resistance we used as P, Q and R, and S is a unknown resistance. So by applying this formula we can get the value of unknown resistance accurately. So from there previously we have got P by Q is equal to R by S. So we can write the equation like this way. P by Q is equal to R by S. So we can write Q by S is equal to P by R. These are the same. Both equations are the same. P by Q is equal to R by S. It means Q by S is equal to P by R. So here we can see that if we interchange the position of galvanometer and the electric source, that means if we put electric source here and if we put galvanometer here, then the null condition of the galvanometer will exist. But in that case the sensitivity of the Wheatstone Bridge will be the different. So in Wheatstone Bridge actually we use P, Q, R and S. These are almost equal resistance. If we use the almost equal resistance as P, Q, R and S, the sensitivity of the Wheatstone Bridge will be the maximum. Now let us see the resistance, because from the Wheatstone Bridge we are measuring the resistance. First one is low resistance. What is low resistance? The resistance which is less than 1 ohm. The resistance which is the value of which is less than 1 ohm, that is called low resistance. Ordinary resistance, the resistance whose value is between 1 ohm to 1000 ohm is called ordinary resistance. So 1 ohm to 1000 ohm, that is called ordinary resistance. And high resistance which is above 1000 ohm. So above 1000 ohm resistance we can say it as a high resistance. Actually we are measuring the resistance, that is ordinary resistance, by applying the Wheatstone Bridge. That means we measure the resistance between 1 ohm to 1000 ohm by applying the Wheatstone Bridge formula. But for measurement of the low resistance and measurement of the high resistance, if we apply Wheatstone Bridge, some error will come, and in that case we could not calculate the value of that unknown resistance accurately. Now application of Wheatstone Bridge. Applications of Wheatstone Bridge. Wheatstone Bridge principle applied in post office box and meter bridge. We will discuss meter bridge afterwards. Now today I want to stop here. Thank you for listening my class. Okay. Wish your best of luck. Thank you once again.